the help that is given by the faculties there. So I'm very much looking forward to listening to your papers and the results and so on. And as I said, I will try to summarize the gist of what it is after the session is over. That all the best, and I now request we will go through now the papers as such. I understand that there are 5 papers in this particular track today. The first 3 of them, I guess they are online, and the last 2 are going to be in person. So I hope I'll get some help to organize these things. Okay. Thank you.
Now I request Dr. Satyanarayan sir to start the session.
Yeah. Okay. So let us start the track 3 on this is the last session, I understand. So the first one, sorry, is paper ID 191, and the title of the paper is An Experimental Investigation of UNet-Based Deep Learning Segmentation for Histopathology Images. I think the first author, I guess, is Swati Vijay. Is that correct?
Yes.
Yeah. Okay. About the time, it's
Yes, the
8 minutes.
so
Hello.
good morning. My name is Sarvesh Babu Sarjavan.
Yes, sir. So you have a time limit of 8 minutes. Within that 8 minutes, you have to complete your presentation, and 2 to 3 minutes will be a question and answer session. You can start your presentation now.
So my name is Sarvesh Babu Sarjavan. I am an undergraduate of Cambridge Institute College of Engineering. The co-authors and my guide was Dr. Swati Vijay Shinde, who is the research lead. Paper title was Experimental Investigation of UNet-Based Deep Learning Segmentation for Histopathology Image. So the outline of presentation will be introduction, methodology, block diagram, results and discussion, and conclusion, and the references that are used for this paper. So introduction. So in the examination of histopathology images, segmentation is a fundamental yet a difficult process. As we know, there are overlapping regions in a histopathology images, which makes it challenging for us to separate the nucleus. And why do we need to separate this nucleus? Because we know that nucleus is the main component that will give us the information about is there any disease or not in that histopathology image. So that's why if we can segment this nucleus out, then our accuracy can we can increase. So the work was mainly related to find the best model of unit with various permutations of optimizer and activation function. So for our work, we use 3 optimizers: AdaGrad, AdaDelta, and Adam optimizer, and 5 activation functions, namely DTRedo, Sigmoid, TANH, Softmax, and Rayleigh. So this was for input layer. The output layer activation function was kept constant as a sigmoid function. So talking about methodology, we use a unit architecture. What a unit architecture is? It is a 2-path convolution network in which one path contracts and other expands. What this model does, it takes the input image, it tries to get the feature out from it using a 3x3 convolution, unpadded convolutions, and then it applies a 2x2 max pooling to get the features out. In this way, we will be calculating the features, and using those features, we will make we will use the upsampling to generate the feature image. Now, what we will do, we will map the from the contraction path with the generate the we can say it is on the contraction path. This correctly being displayed or its features are correctly calculated on the image that we made on the expansion path. So after that, when the model is trained, we will be having the result. The model is saved. We will be first giving the input as the image that need to be segmented and its output for the masked. This will be a masked output, And for this, we have used the sigmoid function in the output layer, and the input layer activation function is changed. So the block diagram was like this, that we will be first giving the input image. These input images will be given to the training phase, and pre-processing is done, because what was there, that this image had this, the cells were masked. Like we have an image for each of the cell, masked cell, and thus we have to superimpose them, and we have to make one single image of all the one cell images. I will show you what was the data structure, means what was the data set structure there. After converting this contraction cell, we will be on expansion path, and our model will be trained. Now for testing, we have used the testing input images. So for training, we have used 570 images, and for testing, we have used 100 images. So this was the segmented output that we had for the testing images, and this was the predicted output for our images by our model. So now how results and discussion. So first we have used AdaGrad optimizer, and leaky ReLU, sigmoid, tanh, and softmax, and ReLU were the function. So we can see that accuracy of tanh is high compared to others, and also its loss is lower than other activation functions. So we can conclude that tanh performs better when we are using AdaGrad optimizer. And this was the results, that for a testing input image of this, the actual segmented output was this, and our model predicted output was this. Now going forward with the ADA delta, we can see that in ADA delta, accuracy is not up to the mark, it is below 0.8, we can say below 80%, and also the loss is above 50%. So we can conclude that either we use any activation function with ADA delta, we are not getting satisfied result. Our results will be having too much loss, or they won't be giving us the correct result. That's why we haven't moved forward and check it for any input image. So now for Adam optimizer, we are having mainly three functions, leaky ReLU, tanh, and ReLU, which are giving us a good accuracy. And talking about loss, we can see that ReLU function is giving us a least loss. That's why we can conclude that ReLU gives us least loss when we ReLU gives us good results when we are using Adam as an optimizer. So this was the testing input image, actual segmented output, and this was the predicted output by our model when we have used Adam optimizer and the ReLU function. Now conclusion, the conducted study was able to determine the best suitable function for the AdaGrad optimizer and for AdaGrad and Adam optimizer, but for ADA delta we had some conflicts, and thus the research can be concluded further for checking what could be done so that the AdaGrad optimizer will have good results and we can improve the accuracy more and more. As the data set was of 570 images for training, we were not able to get accuracy of 99%, or we can say 98%. We were only able to get the accuracy of 96% at max. So these were some references that we used during our paper. So thank you for your time.
Okay, thank you for your nice presentation. I have a few comments, but before that, let me ask, are we supposed to take questions from the audience?
Yes, sir.
Huh? Any questions from the audience? Okay. So I have a couple of questions. So one thing is, you already mentioned also about that regarding the training samples and the testing sample size. So why the numbers are so small?
Because it was the data set, means we have the data set from Kaggle. It was used for a competition, and as we know for unit, we must have the input image and also its masked out. I will show you what the input image and masked output image was. So for now, this is the input image, that we are going to fit to the network for training.
Okay.
And talking about its masked output, these are the masks. We can see that each cell is masked in a one single image. Now, this was a main task for our. This was a complex task that we have to overlap all these images such that we get one image out of all these, which includes all these cells, or we can say these white dots. All these white dots are representing the cells. So this was the main task, and we can see that here 570 images were there of the same structure, and that's why the accuracy was this much low. But if we can get more of such images, like a minimum up to 2000 or we can say 3000, the accuracy may go up to 98% or 97%.
Yeah, I mean, that was my point. See, like, what you showed is for each of the input images, you will have those many dots as so many masks you will get individually. But that is how you run the algorithm, right? But do you have some limitation on getting larger number of test samples or training samples? Is what my question is. And that's okay. So we'll move forward. But where did you show the 96% efficiency? You were reporting you got 96% efficiency, right?
Yes.
Where is that shown in this slide?
Okay, so we just included the graphs on this slide,
Yes.
talking about the tables and all things. So we have tables here. So we can see loss, accuracy. So for ADA grant, we were having a maximum accuracy of 76, then 86 for tannage. That we concluded that tannage is the best for ADA grant. Moving forward with ADA delta, we can see the loss is greater than 0.5 for each, we can say, activation function. That's why we concluded that it won't be helpful for us for moving ADA delta further for anything. Then we are talking about the Adam optimizer. We can see 96 was the highest accuracy given by review function and a least loss of 10, which is 10% loss. Then we also used error measures such as mean absolute error, mean square error, PSNR ratio, etc. And we can see that when AdaGrad was the optimizer, we were having the highest PSNR of 70. But when we were having Adam as an optimizer, the highest PSNR was up to 80. But PSNR is, it shows that how much pixel to noise ratio. So for each pixel, how much there is a change in the, we can say, in the output image. So this PSNR should always be like more than 70 to up to 90 to get the correct output. So that's why we use PSNR. And we can see that we are having a 80 of the score for Adam optimizer and training function.
All right. Yeah, I mean, you are not there in the presentation, that's why I was asking. Okay.
Yes.
Yeah. Thank you.
Yes. So are there any questions?
Yeah, there are no more questions, and thank you very much for your presentation.
Thank you, sir.
Okay. We'll now move on to the next presentation, which is also online, paper ID 203. The title of the paper is Unveiling Intractable Epileptogenic Brain Networks with Deep Learning Algorithms, a novel and comprehensive framework for scalable seizure prediction with unimodal neuroimaging data in pediatric patients. The first author, I guess, is Bliss Singhal. So you can go ahead now with the presentation.
191 is there.
Paper ID 203. Yeah.
173, 205.
Paper ID 173.
Hello, sir.
Yeah.
Hello.
Paper
Hello,
ID
sir. Am I
173.
audible?
Yes, you are audible.
Yes, sir. Am I supposed to present?
Yes, you can start sharing your screen.
Okay, sir. Thank you, sir. Just a second.
Paper ID 173. Please share your
Yes.
screen.
Yes. Is it visible now, sir?
Not yet, ma'am. Not yet.
Is it visible, sir, now?
Entire black screen we are getting to see over here.
It's coming, it is coming.
Is it visible, sir, now?
Only we can see here the message like Deepali Kadam has started the screen sharing. Entire black screen we are getting to see.
Oh. Okay, sir, I'll just check. Okay, screen. Now, sir?
Not yet, ma'am. You just resolve your screen issue till now. Till then, we'll take the next presentation. 205. Paper ID 205. Paper ID 205. Paper ID 173, you can stop your presentation because we are not able to see this. Now it's coming.
Sir, may I just continue, sir?
Okay, please.
Okay. Thank you, sir. Yes, so hello all, good afternoon. This is Deepali Kadam here. My title name is Study of Machine Learning models for predicting mental health through text analysis. My guide is Professor K.T.V. Reddy, and yes, so basically there are like many mental health disorders. These are burgeoning, global public health challenges. Uh, Stigma with these kind of mental health results in delayed health seeking, right? There are many people who don't feel comfortable when they go to the doctor physically, and they feel like someone should not know that I'm going through depression or I'm feeling some low energy. And if you see, so in this Gen Z area, people are more tend to express their feelings through social media platform, okay, through text, through posts, through messages, and they feel comfortable over there. They feel like expressing themselves, whatever they feel, whatever they are having urge to talk about. So they usually go on posting such messages or such kind of posts, and that's why there are many, right now there are many researches going on which are like, they are trying to understand people's emotions and their stress level, their depression level, or there is always there is always a thin line between the actual feeling, actual having depression, or they are, it is just a few days they are feeling low. So yes, there are many people who are working on it, and nowadays in this AI ML era, of course, people are going for machine learning algorithms and some deep learning models for the same. Like you might have heard about Twitter analysis also, where people go for collecting the tweets, and then they do the operations, NLP operations, or deep learning algorithms they use, machine learning algorithms they use to understand what exactly the person is going through. But most of the time, they just try to analyze, or they just try to predict in binary format. What do you mean by in binary format? Like if the depression exists or if it does not exist, like yes or no. But they don't get into the categorization of it. Like depression is a very vague term, right? Like depression is something which is one umbrella, but under this umbrella there are many categories. It can be postpartum blues, it can be somatization, it can be internet addiction. So there are many categories, and hardly very few people have went for these categories, went for these, this kind of prediction where you can categorize, you can classify the actual depression. So we went through many papers, and at the end, like at the end for the study purpose, we went for 21 papers. So here, because of the limit of because of the time limit, I am producing 5 papers over here. Like the first one was predicting social anxiety treatment outcome based on theoretical email conversations. Now here they actually collected data from the 69 patients. So they generated their own data set, but as 69 patients are not, like, is not a very big number. Like in this paper, they at the end they concluded like yes, they use the predictors like basic maybe behavior, word usage, writing style, but these predictors can be improved. The number of predictors can be increased if we increase the data set. Here, they found the random forest as the best paper. As the best algorithm with the 78% AUC. Then there is this application of machine learning method in mental health detection again. So here it is a review paper. Here they found that the SVM for mental health problem detection, they found the accuracy was approximately 70%. And also the and that was the best algorithm they found in this paper. Next was predicting depression symptoms in an Arabic psychological forum. Uh, Now here again they gathered the data, real-time data from the Arabic forum, and it is labeled either they labeled it automatically where they can extract the words, and which is quite self-explanatory that yes it is sad or it is depressive or it is joyful. So there they use the there they went for the automatic extraction, but where it was not so obvious that what exactly the person is trying to say, there they went for the manual labeling. And there they found the lexicon, as I just said that it was a lexicon based approach. So yes, they found this lexicon based approach the best one. And next paper is a depression recognition method for college students using deep integrated support vector algorithm. That is, in short form, they call it as DISVM. So it gives when they so when they perform algorithm, around 80% like it was the 80% is there of training data set and 80% of testing data set. Next, was the multi-level emotion classification on mix, that is data and hertz. So, they want to look at code mix, they use two languages, English and Roman Urdu, and they collected these SMS messages, and on that,
She left this time.
What is
Disconnect. Yes.
hello, am I audible?
Yes, you are audible, but your screen is not visible.
Okay,
Maybe
sir.
some
I
net
guess
issue
some
from your side.
connection issue was there.
Yes.
It is visible, sir?
it's still coming up? Uh, I think it is loading slowly. Maybe you have a slow network. It says it is you have started screen sharing.
Yes, I have already started it. Um, okay, may I continue?
One second. Did you, by any chance, did she send the
Yes,
presentation to
we
you?
have.
So what I propose is that we will share the screen from here, and you can continue to speak because I think you are able to we are able to hear you well.
Okay, sir, okay, not an issue, even
Okay.
that.
So we will share. I think locally we are sharing, and you can actually start.
Yes, sir, not an issue, sir.
Yeah.
But I can see.
Okay, this is 170.
173.
Yeah, actually you have to, Deepali Kadam, you have to stop sharing your screen. Yeah, okay. Yeah, this is the one, right?
Yes, sir.
Okay.
Sir. Next, sir.
Next one, okay. So now onwards you
No.
can tell,
Like, before that, sorry, fourth and fifth paper also. No, no, two slides behind.
yes.
So, yes, so, then the fifth paper was, multi-level emotion classification for four means, that is English and Roman, Urdu messages were collected. For like, they had worked on the 12 emotions. And the best result they found was, like it was the F1 score, so for ML, DL and TL, respectively, like they went for experiments, and the best results they found with this ML, OVR, SVC. Next slide. Next.
Yeah, yeah.
Yes, the slide is changed. Is it visible to you? Processing text for prediction of disorder. Ma'am, I think you have some net issue. You can conclude your presentation.
So basically the methodology we are
Hello?
talking about.
Ma'am, please conclude the session because we are short of time.
Okay. Okay.
So please conclude
Okay.
your presentation.
So, as I just said, like there are so many research already going on, but they are basically limited to, most of the time they are limited to English language, and another part is they are in the binary zone, like yes, it is, they are having depression, or no, they are not having depression. Also on the text analysis, usually people are, they go for the, behavioral changes, and face to face they try to predict it, but only for using with the help of text analysis, few researches have been made. So we are, and categorization has not yet been considered so widely for mental health analysis. Like they, as I said, they just say yes, it is a depression or not depression, but they don't go in detail what is there under that umbrella, like if it is classification 1 or 2 or 3. So these are the basically this is the study, and in future, of course, we will be trying to go for this classification and then implementation. So yes, thank you, sir. This is all from my side. Thank you for listening to me, and sorry for this inconvenience. Please, thank you so much for being patient and listening to me completely. Thank you so much. Any
Okay.
questions?
Yeah. So, unfortunately, we could not hear much about the main body of your presentation due to your network issue. But are there any questions from the audience to the speaker? You can. Okay. I think there are no questions from the audience. But yeah, okay. So just one question. It's you mentioned during, of course, you had a long, a lot of time you spent on literature survey and trying to kind of. You should have just concluded what their main work is. But if you can just tell in one or two sentences. So what is that you added to the knowledge? I mean, you did mention about the binary way of conclusions rather than not quantifying, etc. But can you say one or two words, one or two sentences? Because I'm just giving this time because I didn't hear anything of your main body. So what is that your work specifically added to this understanding?
As in the conclusion part, you want me to repeat?
No. Don't show any slides, but just tell what is the new thing that you added to the field.
Okay. Sir, after doing this study, I got to know one thing, or I found one thing that people are, those researchers are basically just concentrating on binary results, that if the depression exists or does not exist. Hardly or very few researchers have gone into the detail that, okay, if there is a depression sign, then which depression or which, there is a classification of depression, right? Depression is a vague term, it is just one umbrella. Under this umbrella, there are many disorders, like it can be postpartum baby blues, it can be internet addiction, it can be somatization, it can be sleeping disorder, eating disorder. So when people are posting anything on internet, or if even through the mails, or even if they are using any blogs, so or even if we ask them some questions, and suppose even in the Google Forms, they, from those texts, we should be what is my plan in future is we should be able to categorize the actual problem, actual depression sign. Like if it is tends towards the eating disorder, or it tends towards the postpartum depression or maternal depression, or if it tends towards the drug addiction or some internet addiction. So we will be doing that. But that is very less. This is something which has been till now has been less focused by the researchers.
Okay. Thank you.
Okay. Thank you, sir. Thank you very much. Any other question from anyone?
No more. Yeah. Thank you very much for your question.
Thank you, sir. Thank you very much.
Okay. Now, do we have 205?
Yes, sir. Am I audible?
Yes, you are.
Okay. Just a second, sir. I'll share the screen. Is screen visible?
Yeah, it is. It just started screen sharing. Maybe you have to wait for a
I
minute.
just started.
Yeah, it is now. We can see your screen.
Okay, just a second, sir. Give me a minute. Okay, so shall I start, sir?
Yeah. Yes.
Yes.
You
Good
can start.
morning, good afternoon, all of you. I'm Shubhangi Shambarkar, and I'm here to deliver my presentation on paper titled Machine Learning Based Approach for Early Detection and Prediction of Chronic Diseases. So we all know what does mean by chronic diseases. So basically, these are the outline of my presentation. I'll be I'll be very quick in my presentation so that all points should get covered. So these are the outline points that I'll be covering throughout my presentation. So few points I have not listed in my presentation because of the limits of that particular slides, but I'll be explaining those things. So we all know that chronic diseases are the conditions that last an average of longer than 3 months and more than that. So that is according to the US National Center. And the chronic problems cannot be effectively treated and with the particular medications, right? Or it can be prevented with the vaccinations. So the different ages process is the another risk factor for the many diseases. Just like for an example, the persistent diseases which we can include, these are the cancers, arthritis, diabetes, obesity, attacks, dental health issues, and many. So these disease prevalence is increasing in the modern world as a result of environmental factors, which includes the lifestyles of different choices and different person. So it is essential to identify and predict these certain diseases which are early on, and in order to stop them.
Yeah, excuse me, your voice has gone down. Can you speak a little louder?
Yes, yes. Am I audible now?
Yeah, now better.
It is okay.
Yeah.
Yeah, so in order to successfully detect and predict the prevalent chronic illness, my proposed paper is it makes use of cutting edge of different machine learning algorithms. So the proposed system assures the accurate categorization of the people with the chronic diseases using. I have used the hybrid algorithm, you can say, the CNN and the KNN. So CNN style algorithm, so basically it's CNN style algorithm to automatically extract the features and the forecast diseases, as well as the KNN for the distance calculation and data set matching. So the proposed system uses that particular hybrid CNN and KNN, and I have compared different algorithms with name-based linear regression, DT, and so on. So I have used here the structured and unstructured data. So both structured and unstructured data can be used to provide the findings of that extremely results, providing the findings that are extremely accurate. So we are in unstructured data which contains the patient's record from their doctors that includes their symptoms, self-expressed complaint, and it offers an advantage over the structured data.
And again, your voice is going low in between, so please come close to the maybe.
Yes, it is closer towards.
Yeah, but
because,
somehow.
Yeah, I think some network issues might be there, but the mic is in front of my mouth only.
All right.
Okay. So the high dimensionality of these large healthcare data set is characterized by the possibility of recording more features per observation than there are the different observations that we have. So therefore, it is crucial to include not just the information about the diseases, but also the environmental factors which are also related to patient living also. So, for that matter, the machine learning algorithm methods provides the efficient answers for this particular basic problems which are related to the high dimensional data sets. So, these techniques basically helpful for people who need to take care of themselves in order to improve their health as the self-management also. So, by using this, we can use the mobile applications also. Hello.
One second. Your screen shows. Yeah. Just now the screen moved. Otherwise, it was in intro section, intro slide till now.
Okay.
Unfortunately, there are no page numbers, no slide numbers. So right now, the screen says the proposed system.
Yeah, it is there.
Okay. So far you are at the introduction slide, the previous.
Yeah, basically I was just explaining the introductory part, so that's why I have not moved on those slides. I'll be coming towards the methodology.
Yeah, but you already spent a lot of time. Yeah, please go ahead. Yeah.
Okay, so I'll be taking a short time. So the main goal of my project is to develop the compressor system that can accurately identify and predict the likelihood of person development chronic conditions using the different machine learning technique. For that I have compared different algorithms such as support vector machine, logistic regression, decision tree, and all those. So all those things are not, the comparative study has been there, which is listed in my paper. The advantages, limitations, and what would be the future scope that I have. It has been listed. So the particular, I'll just explain like CNN and KNN. So in CNN, what I'll be taking is that take the input data and applies the biased and weights to the different components. So for that matter, the algorithms is being done. So according to that, I have to work on it. The proposed data can be included for the training and testing of data. So convolutional layer has been there, the activation function has been there, the pooling layer. So all those things they'll be having their proper work to do so. Then for KNN algorithms, so it can be used for both classification and regression tasks. So and the proposed the slides which has been showing the methodology part. So in that it has been listed in this particular block of data. So what data collection is the very first step in the particular process, where it has been suggested and they collect it with solutions that collects the various sources. So data is cleaned and divided into training and testing data sets during that pre-processing. So which follows the data collection. And then the training data set is used for repeatedly train the machine learning algorithm, which I am using, that is CNN and KNN. So to increase the precision of the prediction outcomes, that would be the most of the goal of the iterative procedure. And the model is ready for testing once the appropriate target accuracy is trained. So the data set is used to access the model during the testing phase. This data set is made up of entirely of fresh information that wasn't utilized in the training. So, and then
Yeah, you're actually running short of time, so maybe you should just spend 1 minute on the conclusions.
okay, so okay, fine. So the result analysis part, the accuracy and all, what will be calculating is it depends upon the 4 factor, the number of accuracy predictions. So that can be, we can say that is true positive value, the number of accuracy prediction where the model probably identifies people who without any diseases, that is true negative, then false positive and false negative. So those are the factors. And then the precision, the F1 recall, F1 score, and the so on that particular parameters, the basically different algorithms has been worked. And what we have found is that CNN and KNN has the most of the accuracy amongst the different algorithms. So, and that particular graph shows the performance comparisons of different methods also. And if we see the accuracy point of view, the CNN and KNN has more accuracy, depending upon the different algorithms which we have compared. So, and the conclusion part. So, to basically identify and forecast the occurrence of chronic diseases in patients, this study is employs of 2 machine learning techniques, which has been for the use for the real world data sources. So, it stands out from many other approaches. Just we have seen the different result analysis based on that. It comprises of 95% accuracy, 94% of precision, and 99% of the recall rate. So that's why we can see that CNN and KNN algorithm, it uses both structured and unstructured data for the prediction of the chronic diseases. Thank you. These are the references. Thank you so much.
Okay, thank you. Once again, if there are any questions to the speaker from the audience. Okay, you want to ask me a question? Okay, thank you.
Thank you so much, sir.
Okay. Okay, thank you.
Online.
Sure, sure.
Check it fast.
245.
245.
245 is there.
Is that the 245?
Ma'am, if they have pen drive, they can okay go that now.
Yes,
Go,
it
go, go,
is
go.
245.
Why so completely?
Sir, please. Down. Pointer, yes. Fast.
Can I work screen share?
Screen share.
Yeah, I will share. Sir, 1 minute.
Very good afternoon, sir, and very good afternoon, audience. I, Nilesh Singh B. Thakur, presenting a paper titled Medical Image Fusion using Discrete Wavelet Transform in view of deep learning. My co-authors are listed there. Now, why there is a need to have, this is what the outline of my presentation. Finally, I would like to tell you why there is a need. Excuse me, sir. Will you little bit?
It is like
Now, what basically the image fusion is and why there is need to have the image fusion. Now, all of you know the fusion and fission reaction. Fusion, once you did the fusion, later on you are having a scope to separate it out. It is a sort of mixture. And the fission is a sort of compound, as you know about the chemistry reaction. Now, in general, in medical, what happens generally when you used to go to doctor used to ask you to go for the sonography, X-ray, CT scan, and MRI. And later on, it is having the different steps. So first X-ray, then sonography, then CT scan, and MRI. And then the doctor comes to the final diagnosis. Now, rather processing the things in a stepwise manner, if you do have all the things available at a time, and if you go for this different modality images collectively, and if you are getting simply a single image and which can be capable to tell you what exactly is happening or what is there in that typical fused image. So here there is an attempt to fuse the CT scan images and the MRI images associated with the brain tumors. And later on, those brain tumors images, fused images are get categorized into the whether the brain tumor is available or not available. So final aim is to have the classification into the two classes, whether brain tumor is available or not available. But as I titled the paper, in view of deep learning, so all of you know in a deep learning, you used to make a model, and when you are going for training, you cannot be biased to have only 500 or 1000 samples. So if you are having a more number of images to train the model, then it will give you the better result subject to condition. There are not many other parameters out there. So we were in a lack of the data set which is available right now. So what we did, we have selected 38 images of the CT scan and 38 images of the MRI of the same person who are having the brain tumors and who are not having the brain tumors. Now where from we have collected this data? Not many data sets are available. We have taken all these 38 images from one typical data set. Now here M, Our aim is to identify, because our aim is to have the huge data set from deep learning point of view, which we are not having. So we have decided to create the data set by using some pre-processing. Now, what sort of pre-processing is possible? So we gone for the wavelet. There is another transform, Fourier transform. In a Fourier transform, there is a one lacuna where you are going for the stationary signals. The Fourier is performing well, but for non-stationary signals, there is a issue. So what we have decided to go for the wavelet. Now on right hand side, the second point you can see the wavelet. There are the different wavelet transform families. Around 60 plus total transformations are available. We have decided to take few of them. Typical 4 families we have explored. And how the wavelet works, there is a frequency on horizontal axis and time on vertical axis. If you do take, this one is the frequency axis and this one is the time axis. In a simple Fourier transform, the whole image is divided into some typical blocks, and that is not the case with the wavelet. Wavelet decomposes the image at a time into the 4 parts with respect to frequency and the time. And that is what the beauty of the wavelet, where we have divided the detail approximation and the little bit approximation, where the approximation coefficients are created. One is the part of detail coefficient and other one is the part of the approximation coefficient. Now, from literature point of view, which particular papers we have scanned, being we have to study to identify which wavelet will perform better, which will produce the better data from our deep learning model point of view. Now, from that point of view, we have scanned the research paper. Most of the papers which are associated with the reviews and the surveys associated with the image decomposition and fusion. Now, decomposition, when you do, the whole image is get divided into different parts. For example, one image you are having, you are cutting it into the 4 parts. Then every part you are cutting into the 4 parts, and if you keep on doing the same thing, finally you will get the 1 pixel data. Now, this one is what known as the quad tree decomposition. Likewise, wavelet decompose the thing with respect to the frequency and the time. Now, from that point of view, we have studied the review papers. We have gone through the lot many review papers associated with the wavelets and associated with the data fusion. Now, simple data fusion, for example, if you are having a data related to one student, maybe his numerical values along with the alphabetical values, you may merge them and you may get some typical representation. For example, your enrollment number. That enrollment number is the fused data of lot many things. Though we are going in a different way, you get the one enrollment number, based on that other data is created. But take the case that you have collected all the data and based on that you have created the new enrollment number, and that is what known as the fused data. If you decompose it into different parts, you can reach to your original data. Then, as we have decided to go for later on for the deep learning, from that point of view, lot many research have been carried out related to image fusion and deep learning. Here you can see the few of the papers. The listing is given around the prominent papers I have included here in the presentation. Now, what we have learned from after doing the research literature survey, we found that the full wavelet families are not explored in a depth. Now, issue is what? If you go through, if you scan the net, you will find few of the papers talking about some typical family, Dovic's family, or example, Simlet family. But not all the families are explored and no one has concluded as per our knowledge. I'm not claiming, but as per our knowledge, we found that no one has claimed about which particular family is good for the medical image fusion. So what we have carried out the experimentation, and our sole aim is to explore the full wavelet families, and another aim is to create the huge data set for the deep learning model building point of view. Now here you can see the CT image and MRI image where we have applied the discrete wavelet transform, and based on the HAR, Dovich, Simlet and coefficient let. Everywhere you will find the word LET will come down there. the image will get decomposed into the LL, LH, LD, and LV. LL consists of around the approximate information about the particular block of that image, or else if you take the full image, it will represent the approximation of the image in the LL. LH is the horizontal details of the image. LD, it is a diagonal details, and LV, it is a vertical details of the image. So DWT decomposes an image into different frequency bands. So low frequency band and the high frequency band. Now, based on that one, we have designed the procedure here for CT image and MRI images. We have identified low-level features. Likewise, for the low-level features for the MRI image. And later on, based on these two values of CT and MRI, then we have devised our algorithm where we have explored the three types of things: minimum value, maximum value, and the average value. That is the mean value. So here you can see the discrete wavelet transform. Here on the left hand side, third point, third, fourth, fifth, and sixth, we gone for the different values of LL1, LL2, and LL to produce the fused image LL value. So we have taken the LL1 and LL2, likewise for the LH1, LH2, LV1, LV2, and HH1 and HH2. We have taken the maximum of both of them. Like so for CT image, you are having the LL1 value. Likewise, the MRI image, you are having the LL1 value. Now, three combinations are possible. Either select the max of these two, or else select the minimum of these two, or else take the average of these two. Likewise, 9 combinations are possible. We have used 38 images for every pair, 38 CT scan, 38 MRI. For every pair, 9 combinations are possible, and around 50 wavelet transformations we have used, which created around 17 to 18,000 images, wherefrom we have selected typical and kept it for our deep learning model. Now these are the results. Here you can see on the top left, it is a max-max combination of one of the pair. It was just impossible to accommodate all the results here. So max-max, center one is the max-min combination. Third one is the max-min combination. Center row min-max, min-min, then min, MIN, then min-max, min-min, and MIN. Minimum values. Now here, finally we concluded that based on all those experimentations, we found that we are getting the better result of the fused image in the max-max combination. But we have not discarded the remaining data. We have kept it to make the model better, but that work is going on right now. And here the sample is given on that right hand side image. You can see the CT image is there, and in the center it is the MRI image, and on right hand side you can see it is the fused image, which can give the details. Now there are lot many parameters to study which are involved here. You have to divide the image, you have to segment the image, the features based on what we have fused the image. It is based on all the wavelet coefficient values related to LL, then LV, LH, and HH. But in future, parallelly, we are going to create our data set in a more big way, where we are going to explore the textures, color, and all those detailed segmented data, skeleton data, and lot many descriptors are there. Chain codes we can use there. Okay. So, final conclusion based on all this. Here we have identified that the family DB is performing well, DWG is performing well. Within that, we got the max-max results are better in every family around 90 to 95%. We got the better result for the max-max combination. Then features which are obtained in the max-max gives the better result. And based on this preliminary work, the baseline work from deep learning point of view, if anybody is interested to work in a medical image fusion, this paper can become a good referral paper for them. These are the references which are referred from the prominent refereed international journals, typically from Eurosip.org, then Hinvi.com, then IEEE and ACU. Thank you one and all. Thank you so much.
Thank you for your paper. Are there any questions from the audience to the speaker?
I love to have the questions from audience. Because students can ask me the question. Being a teacher, I love to answer.
Okay. Looks like you don't hear anything. I have a couple of questions to ask you.
Yes.
Of course, you try to kind of use images from CT and MRI, for example.
Yeah.
But is it not that the images or the diagnostics point of view, either a CT or MRI is prescribed for some specific purposes, isn't it? Because let us say for soft tissues you will use MRI, for regular images you use CT, and so on. So I still don't understand how do you gain diagnostic value by combining images which are prescribed for different modalities. So because these are not the same, right? I mean,
Yeah.
if you take one soft tissue image, another soft tissue issue, and enhance the image quality by fusing them, that I can understand. But here they are meant for two different purposes.
Yeah.
So I want to ask.
Yeah. You are quite right.
Yeah.
I would like to address that issue. If you are having a CT scan of the one person, you will take a CT scan of particular region of the head or the brain, and for the same region you are taking the MRI. The difference between resonance image and the CT image is that it is about the detailing of the images. Consider, for example, this much size image you are having, a square shape image, for instance. Then there may be some block which is get identified, which is not a regular appearance, which is get experienced by the professionals, medical practitioners, like the ECG. Some typical format, they know this one is the normal. If anything wrong is happening, they can able to identify something wrong is happening. Likewise, they are quite aware about the typical CT scan images of brains of one individual person. But if there is any problem, what the CT scan, how the pathologist or that radiologist is writing the report, it is based on that tool provides them the detail. Something wrong, appearance is appearing there. The same thing is there with the MRI. Now our tool will do what? When later on we will segment the image. For example, this one is the brain tumor image. This MRI is the brain tumor image. On the contrary, we are having no brain tumor image. Now there is a difference between brain tumor CT scan and no brain tumor CT scan. Now that can be get located, and due to that distortion in the images, the values may get changed. We are collecting those feature values. Being sir, here we are assisting a doctor. We cannot conclude perfectly. Yes, 99.99% disease is there. We have to see the standard data set is saying the brain tumor is there. Later on, we have to see how many misclassification will be there and how many times it is classifying in a better way. We are expecting a good result because previous work, what we have carried out for the classification, basically we are planned to go for the Boltzmann machine as an example for the training in a deep learning. Right now my work is doing.
Yeah, so the other question is, you said you had worked with 38 images of CT and MRI. So, I didn't quite see the exact summary or results of these. Were you able to compare, let us say I take your approach of taking 38 images of MRI CT and maybe the same 38 images or whatever, of not fusing these images, but the radiologist will see them independently or whatever it is. So therefore the diagnostics, yours may be 99, maybe the radiologist maybe 98 or whatever. I mean, is there such quantitative comparison? I did not see.
Let me tell you, I forgot to tell you one thing. Whatever the fused image I am going to get, it will get compared with the ground truth image. Already in a data set, the fused ground truth is available, but not huge data set is available. Now, whatever our fused image, it is get compared with the ground truth image based on the PSNR. Second thing, SSIM. self-similarity index measure, and MI, that is the mutual information. That we have evaluated, we have restricted our paper, being the length of the paper is minimum to 6 pages, 6 to 8 pages. So what we have restricted our paper, that results are available with me, sir. We got the better result for the SSIF, MI, and the PSNR related to ground and particularly with the max.
Thank you. Thank you. Thank
So
you.
nice of you. Thank you so much.
Yeah. Bye.
Ma'am, I will present one video of 203 from she is from USA. I will share.
203 actually she is not present online, so we will play the video for 203 and 125 also.
Hello, my name is Melissa Sinkoff, and I'm very excited to present my research on unveiling intractable epileptogenic brain networks with independent component analysis and deep learning. In this, I propose a novel and comprehensive framework for scalable seizure prediction in unimodal neuroimaging data for pediatric patients. I focused on intractable epilepsy, in which seizures cannot be controlled by medication. This occurs in 30% of children with epilepsy, and it causes depression, stress, and limitations in their day-to-day activities. There are a few medical options for these children, but they are not suitable. For example, epilepsy surgery is very risky and unapplicable in many cases. Additionally, using biomarkers from wearable devices to predict seizures have a low predictive range. And finally, neurostimulation therapy is too invasive. My focus is to analyze the effectiveness of state-of-the-art machine learning algorithms, including deep learning to predict seizures in children. I set multiple engineering goals, including maximizing the signal-to-noise ratio in the dataset, implementing a cost-effective and practical solution that utilizes a minimum number of EEG channels used, achieving a high performance of the overall framework by leveraging a range of classification algorithms, and finally testing these models on different time intervals before seizure onset. To talk a bit more about my dataset was 50 gigabytes of EEG data taken from the Children's Hospital in Boston and MIT. This data consisted of 24-hour EEG recordings from each pediatric patient, as well as a summary file detailing the start and end times for the seizures in each recording. To provide an overview of my design methodology, I first extracted and visualized my data. To pre-process my data, I first converted my data into epochs. I then generated labels for each of my epochs, and then divided my dataset into a training dataset and a testing dataset. I then implemented bandpass filtering and independent component analysis to reduce the noise and artifacts in my data. I then used 3 novel deep learning algorithms, LSTMs, RNNs, and CNNs, as well as 2 other novel classification algorithms, logistic regression and k-nearest neighbors. I optimized the hyperparameters and trained the models using binary cross-entropy. Specifically for my deep learning algorithms, I built custom neural networks, which included neural network regularizers. To assess the prediction model's performances, I evaluated 6 different metrics: precision, accuracy, specificity, sensitivity, F1 score, and Matthews correlation coefficient. I tested my models on 11 different time intervals, ranging from 20 minutes to 12 hours. I then compiled blocks plots for each metric in each of the deep learning algorithms across each time interval. And I noticed that metric performance declined significantly after 60 minutes, and then again after 6 hours. For example, my LSTM accuracy went from 80% to 79%, to 77%, and then to 75%. And this trend continued in my 4-hour to 12-hour time intervals. Overall, deep learning outperformed logistic regression and k-nearest neighbors. And then when comparing within the deep learning algorithms, LSTM and RNN had similar performances overall. CNNs had the highest specificity, and LSTMs gave the highest sensitivity and accuracy for the 20-minute time interval, and RNNs gave the highest precision. In conclusion, RNN gave the highest precision of 87%, and CNN gave the highest specificity of 99.99% across all the time intervals. Also, 1 hour was the maximum time to predict seizures with very high performance overall, and it received the highest accuracy of approximately 80% from my LST model, with the prediction time of 1 hour before the seizure. 6 hours was the maximum time to predict seizures with adequate seizure prediction, as after this limit, metric performances declined significantly. My research is the first in the world to predict seizures at such long time intervals, as prior research focused on only predicting seizures seconds or minutes beforehand. This has massive implications, since my solution is able to serve as an early warning system that gives children and their families adequate time to prepare for a seizure occurrence, as well as allows children to be able to do many more activities with the knowledge that the seizure is unlikely to occur. It also reduces stress in children and their families, since now they have more certainty about whether a seizure will occur or not. My prediction model can significantly impact millions of children by proactively managing seizure occurrences and empowering them to go about their daily lives with confidence. Additionally, I selected 10 out of 23 channels that had the highest performance in predicting seizures. For future work, different training and testing datasets consisting of different age groups can be added to generalized prediction models. A labeled dataset containing various types of seizures can be used to predict the effectiveness of this model, and different classification algorithms can be explored for different performance metrics in prediction. These are my references, and thank you so much for listening to my presentation. Hello, my name is Bliss Singhal, and I'm grade 7.
Ma'am, Shweta ma'am, 125 है क्या यहाँ पे? Ma'am, which one? 135. 25. Last. Search करो. Search.
Creative action. Implications will be found in people aware of diagnosis and medications. They want to do this this is a problem. It is a problem. Precise techniques are used to analyze and process information objects that In medium to computer-aided diagnostic, two detailed anomalies include automatic detection and quantitative analysis of the radiological images in the blood. As we know, these samples are taken most precisely for those who are just undiagnosed symptomatic is a risk person. These also beautifully also notification is not only to be the early detection. The first 108 detection system was primarily used for clinical evaluation. The same company used radiological images. Looking how to evaluate CAD computer-based detection system. First, we will stand on execution. The result of this technique is this exercise is highly dependent on the category. This CAD system sensitivity and specificity mean that based on this issue configuration, proves statistical significance performance supremacy of the totality of the CAD system. Equal numbers of theories. And the second one is the laboratory research on the potential detection enhancement. In this involvement, the reader may overestimate or underestimate the number of cases they use. In this technique, this research compares sensitivity and callback rates of readers without CAD guidance to those using CAD technology, aiming to predict the benefits and predicts changes in disease identification, capacity building. And the third one is extensive clinical practices experiences. The result of the technique is in actual clinical practices setting, assess the CAD goals with the lack of care. In this evaluation process, assess of the CAD, clinical practices evaluate solution of various
करा दो बंद कर गेट बंद कर जॉय बंद कर
as they